Spiritual message. Namo Kal Kalne, Namo Sarv Pale, Namo Sarv Gaune, Namo Sarv Paune. अर्थात salutation to thee, O death destroyed Lord. Salutation to thee, O sustainer Lord. Salutation to thee, O all pervasive Lord. Salutation to thee, O sustainer Lord. Unit 6. Principles and processes involved in the extraction of elements. Part 3. Dear students, in the previous two videos, we have done concentration of ore or ore dressing. In other words, we eliminated the gangue particle from the ore. Here, we are going to extract the crude metal from concentrated ore. The B portion is extraction of crude metal from concentrated ore. Usually the sulfide ore is converted to oxide before reduction because oxides are easy to reduce. Thus, isolation of metal from concentrated ore involves two major steps. First one is conversion to oxide. Metal is in any form, it may be in sulfide form, it may be in carbonate form, but first of all it is converted into oxide form. And then reduction of oxide to metal is done. Now, first one is the conversion to oxide. Two processes are there. First one is the calcination. Calcination involves heating when the volatile matter escapes, leaving behind the metal oxide. Calcination involves the heating of the metal in the limited supply or in the absence of air. The first reaction is showing iron oxide with X water molecule. When heated, it eliminates water of hydration and we get Fe2O3. Similarly, zinc carbonate is converted into its oxide and calcium carbonate, magnesium carbonates are converted into their oxides. And second one is the roasting. In roasting, the ore is heated in a regular supply of air in a furnace at a temperature below the melting point of the metal. Some of the reaction involving sulfide ores are sulfides are converted into oxide here. Sulfides for zinc sulfide, lead sulfide, copper sulfide, all are converted into their oxides as shown in the equations. The main difference in calcination and roasting is therefore calcination involves heating in the limited supply or absence of air, or roasting it involves the heating of the ore in excess of air. In calcination, carbonates are converted into oxides. In roasting, sulfides are converted into oxides. Note, the sulfide or copper are heated in a reverberatory furnace, special kind of furnace. If the ore contains iron, it is mixed with the silica before heating. Iron oxide slags off as iron silicate, and copper is produced in the form of copper matte, which contains Cu2s and Fe(s). We have iron oxide as impurity and we are adding from outside SiO2, which is acidic, and FeO2 is a basic impurity. Therefore the flux added will be acidic. SiO2 is a flux and it combined with the iron oxide and form highly fusible material FeSiO3, that is a slag, which is very lighter and float on the surface and can be easily removed. Very important question, what is a flux? Flux may be acidic or basic depending upon the impurity. Impurity is acidic, flux is basic. If impurity is basic, flux is acidic, and flux combine with impurity and form the slag. Now, reduction of oxide to metal. In the first step, we have converted the ore into its oxide. Now, oxide will be reduced into metal, crude metal. Reduction of the metal oxide usually involve heating it with some other substance acting as reducing agent, carbon or carbon monoxide, even another metal may be used. The reducing agent carbon combined with the oxygen of the metal oxide as shown in the equation. Metal oxide with the carbon and carbon eliminate oxygen from metal oxide. Note, to understand the variation in the temperature requirement for thermal reactions, pyrometallurgy, and to predict which element will shoot as the reducing agent for a particular metal oxide gives free energy, interpretations are made. Now, thermodynamic principles of metallurgy, very very important. Gives free energy is the most important significant term for this. Gives free energy or simply gives energy is described by the relations delta G naught equal to delta H naught minus T delta S naught, or another equation is delta G naught is equal to minus 2.303 RT log of K. K is the equilibrium constant. These equations help us to conclude when the value of delta G is negative, only then the reaction will proceed, otherwise it will not proceed. If the reactant point number 2 and product of two reactions are put together in a system and the net delta G of the two reactions is negative, the overall reaction will occur. So, conclusion. So, the process of interpretation involves coupling of the two reactions, getting the sum of their delta G and looking for its magnitude and sign. Very very important question, a Lingam diagram. This provides a sound basis for considering the choice of reducing agent in the formation of oxides. The plot of gives free energy, standard gives free energy delta G naught versus T for the formation of the oxide is known as Lingam diagram as shown below. Along x-axis temperature and along y-axis delta G naught is given, and downward along y-axis negative value of delta G is increasing, and some curves are also shown in the diagram. Now, first point, Lingam diagram normally consists of plots of delta G naught versus temperature for the formation of oxides of element, that is metal is combined with the oxygen and forming is the oxide. That is affinity for oxygen is shown by this diagram, a Lingam diagram. Each plot is a straight line except when some change in phase, that is solid to liquid or liquid to gas, takes place. The temperature at which such change occur is indicated by an increase in the slope on positive side. There is a point in a curve below which delta G is negative. So MXO is stable. Above this point, MXO metal oxide will decompose on its own. Now, point number D, the value of delta G naught for the formation of oxide at different temperature are depicted, which make the interpretation easy that which metal will be used as a reducing agent for which oxide. Note, thus, coupled reaction of metal oxide reduction with a suitable reducing agent will be spontaneous when the curve of the oxide of reducing agent lie under the curve of metal oxide to be reduced. That is, lower one will reduce the upper one. Okay, lower one metal will reduce upper one oxide. The reducing agent will be lower one, having larger negative value of delta G. Okay, now we may conclude in short, lower curve metal can reduce upper oxide. Now, limitations of Lingam diagram. First one is the graph simply indicate whether the reaction is possible or not. It does not give any information about the kinetic of the reaction because it is based on the thermodynamic concepts. Now, second one is the interpretation of delta G naught is based on K, that is equilibrium constant. It is pre-assumed that the reactant and products are in equilibrium. This is not always true because the reactant products may be solid. खाना पीना हंसना बात जब लग हृदय ना आवे याद. How useless are eating, drinking and laughing if the Lord is not cherished in the heart. ਫਰੀਦਾ ਬੁਰੇ ਦਾ ਭਲਾ ਕਰ ਗੁੱਸਾ ਮਨ ਹਟਾਏ, ਦੇਹੀ ਰੋਗ ਨਾ ਲੱਗੇ ਪੱਲੇ ਸਭ ਕੁਛ ਪਾਏ. Free the answer evil with the goodness. Do not fill your mind with anger. Your body shall not suffer from any disease, and you shall obtain everything. Thank you for attending the lecture.